This video covers the binomial expansion for A-level pure maths. We will go from Pascal's triangle through the binomial coefficient formula into full expansions, the general binomial series for non-integer powers, and finish with a numerical approximation. We will follow a full process first, then a simplified recap at the end. Let's start with Pascal's triangle. Each row starts and ends with 1, and every other entry is found by adding the two numbers diagonally above it in the row before. Here are the first 5 rows built up one at a time. Notice row by row the numbers 1, then 1 1, then 1 2 1, then 1 3 3 1, then 1 4 6 4 1. Each new number is simply the sum of the two entries above it. The key idea is this: each row of Pascal's triangle gives you the coefficients you need to expand a bracket like a plus b raised to the power matching that row. Now let's connect this to a formula. The binomial coefficient n choose r equals n factorial divided by the quantity r factorial times the quantity n minus r factorial. If you compute n choose r for n equals 4 and r equals 0, 1, 2, 3, 4, you get exactly 1, 4, 6, 4, 1, the same numbers as row 4 of Pascal's triangle. The formula and the triangle are two ways of describing the same thing. Before we expand a plus b to the power 4 fully, pause for a moment and predict the coefficients just by reading row 4 straight off Pascal's triangle. The coefficients are 1, 4, 6, 4, 1. Now let's use them to expand a plus b to the power 4 term by term. We write a plus b to the power 4 equals a to the 4 plus 4 times a cubed b plus 6 times a squared b squared plus 4 times a b cubed plus b to the 4. Each term uses one coefficient from Pascal's triangle, and the powers of a count down from 4 to 0, while the powers of b count up from 0 to 4, always adding to 4. Now for point 4, the general binomial series. When n is not a positive whole number, for example a fraction or a negative number, we can still expand the quantity 1 plus x to the power n, but now the expansion goes on forever as an infinite series. The general binomial series states the quantity 1 plus x to the power n equals 1 plus nx plus n times the quantity n minus 1, all divided by 2 factorial times x squared plus n times the quantity n minus 1 times the quantity n minus 2, all divided by 3 factorial times x cubed plus more terms. This is only valid when the modulus of x is less than 1. Let's find a specific term. Take n equals a half, so we are expanding the quantity 1 plus x to the power 1 half. The x squared term has coefficient 1 half times the quantity 1 half minus 1, all divided by 2 factorial, which works out to negative 1/8. So the expansion begins. The quantity 1 plus x to the power 1 half equals 1 plus 1 half x minus 1/8 x squared, plus more terms, valid only for the modulus of x less than 1. Before we use this to approximate a number, predict which term of the expansion becomes small enough to ignore. Think about what happens to the terms once x itself is small. Once the modulus of x is small, each extra term shrinks rapidly because you are multiplying by another small power of x each time. So keeping just the first few terms already gives a very good approximation. Let's approximate the square root of 1.02 using this series. Here x equals 0.02. So we substitute into 1 plus 1 half x minus 1/8 x squared. This gives 1 plus 1 half times 0.02 minus 1/8 times the quantity 0.02 squared, which equals 1 plus 0.01 minus 0.005. Adding these together gives approximately 1.0995, a very close approximation to the true value of the square root of 1.02, using only 3 terms of the series. Finally, point 6, a very common sign error. When you expand the quantity a minus b to the power n, you must treat it as a plus, open bracket, negative b, close bracket, to the power n, so the sign alternates from term to term. For example, the quantity a minus b to the power 4 equals a to the 4, minus 4 times a cubed b plus 6 times a squared b squared. minus 4 times a b cubed plus b to the 4th. Notice the signs go plus minus plus minus plus. Forgetting to alternate the signs and instead making every term positive is the single most common mistake here. Let's now recap everything with the full process in order. Step 1. Build Pascal's triangle. Each entry is the sum of the two above it. Step 2. Use n choose r equals n factorial divided by the quantity r factorial times the quantity n minus r factorial to get the same coefficients. Step 3. Expand the quantity a plus b to the power n, term by term using those coefficients, with powers of a decreasing and powers of b increasing. Step 4. For non-integer or negative n, use the general infinite series, valid only when the modulus of x is less than 1. Step 5. Substitute a small value of x to approximate a number, keeping only the first few terms. Step 6. If b is negative, alternate the signs term by term. Watch out, the most common mistake is forgetting to alternate the signs when expanding the quantity a minus b to the power n, since b is negative. Here is the simplified version. Pascal's triangle gives binomial coefficients by adding pairs above. The formula n choose r equals n factorial divided by the quantity r factorial times the quantity n minus r factorial matches those coefficients exactly. For a plus b to the power n, expand term by term with decreasing powers of a and increasing powers of b. For non-integer or negative n, use the infinite series, valid only for the modulus of x less than 1, and keep just the first few terms to approximate numbers. Always alternate signs when b is negative.